Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3.
What's up, folks? This the damn savage scientist Ed, governor of the state of Swampland. And let me zoom this camera back so y'all can see me. Talking to y'all, I'm gonna do some programming today. But first, I'm straight in here. Straight in this bitch. And put the comments on the screen here. Because that's what's important. Seeing what everybody got to say. Let me get this. Let me do this again one more time. Expand the comments out. Here we go. Right here. So, I don't know if y'all can see that. Y'all can't see that, huh? So far we have, in this chat, we have Kenny Man Early, the earliest person in this chat. So let me see if I can turn the volume up because I can't hear shit. So how I'm sounding? One in the put a one in the chat if you can hear me, and a 2 if you can't. I mean, when I say hear me, that means I gotta be sounding good. I can't find my glasses, so I gotta rock with these right now. So I got these cheap shitty glasses right now. So I'm looking to see, can y'all hear me good? So I'm guessing Two Phones said he could hear me. So we got Jason C in the building, Two Phones in the building, Kenny, and we probably gonna have a few other people in here. But today I'm gonna talk about, we're gonna do a little coding. But first, let me just talk. See, I got my agenda back here. All right, so this is important right there. Let me erase that. All right, all of this shit isn't important. All right, so we got all that crap out the way. We're gonna talk about some C++ today, and specifically keywords. So we got Barry Johnson in the building and Professor Black Ops. See, I'm rocking between those left and right salutes like that. Baby boy in the building too. So we're gonna talk about some C++, and I think it's getting close to that time. So by us getting that out the way, let me start up some things in the background here. All right, because I just want to make sure I'm completely audible, 100% here. 2 zeros. You see, that's the 2 zeros, and that's the 1. 100% audible. So let me get this rolling right here. I'm just working on a few things in the background. All right, so I got that fixed. So let's start talking about what we're gonna do here. So anyone with any computer issues or anything specific to Windows, or have y'all heard about these new vulnerabilities that let me see if I can find that story right quick. I'm trying to find this story. Let's keep that there. So one of the things that we're going to be talking about, let me get this out the way here. I'm just highlighting everybody comment, letting you know that we do have some ones in the comments. We got 3 of them. That's what I'm talking about. Where is my damn pen? All right, so we're gonna get straight into this issue here. So last time we picked up, I left off. I was talking about decks. And exactly why is it good to have a phone? To have it so like if you crack the screen on your phone, you're screwed. You're pretty much out of luck. But with decks, you always have the option to be able to connect this thing back to your phone, and you can see things again. So what I'm going to do is I'm going to show you what I'm talking about here. Let me get my comments back over. So, what I have is, I have this tablet. Unplugging it, and I'm about to. Yeah, I know. That's because I unplugged this tablet. This tablet was the second display, so I unplugged it so I could plug decks into it. So I have a Note 8 that doesn't work at all. This is my Note 8 from. It's dead. You see this? And I have my S22 that's actually making all kind of noise right here. That's what happened when you have Ring installed. So let me get the wire to connect this. And this is one of the best things about having decks. And I'm about to set this right here. I'll be damned. Goddamn wire not anywhere to be found. So when you plug in your phone in a DeX on a PC, it's gonna connect. I can't move this toast notification over, but this is what you normally will get. You'll be able to see all the contents. So you see this. So you have access to the file system. That's one of the things that make it so when you have an Android phone, it's a lot easier to recover your data or anything. But if you can't see the screen, you can't do this, because it's going to ask you about this. You have to give the phone permission. access phone data. So whenever you get a phone access, then, and I know all of y'all done this before, I just hit allow. So now you see how the external data popped up, and as you can see, I have 128. This is the 128 gig version. So I'm plugging it. Now I'm about to show you what it looked like in Dex. Fuck is my wire? First, you're gonna take one wire and plug into the tablet. Got that side done. And I want you to be able to see this. So now the monitor is turning on. This is a terrible cable. I might have to hold this cable up for a little while, but so let me hit start. Alright, so now I won't have any problems. This is another thing, when you use this big, my case was getting in the way, so let's try this one more time. We can see it, but so the reason why this is happening, because I have two displays hooked up. So you still can hear this, right? All right, so there we go. So I finally got Dex hooked to the phone, and something is going on with this damn wire. Yeah, so the wire keep coming out the damn phone. I have to hold this wire up. Alright, so there it is again. Alright, so long as I don't touch anything, you can see that we have Dex on in action. So if you ever break your phone or do anything to the screen, you could always use this. You have access to everything on your phone. And you just have to make sure you have a pretty good solid connection. This wire, there's a short in this wire, so you can't really see anything, but so that's it. So you see how easy it is for this wire to cause problems. So I just wanted to show you quickly how easy, why I would use DeX. So if I'm disconnecting, if I got a broken phone, a broken screen, like this phone, I'm trying to get it back on the screen. That's not the right one, but I'm looking for my S10. So I really want to get back into my original example and why we here today, and that's to continue with this coding. So I just wanted to give you a quick demo of DeX, and now it's time to open up Visual Studio, put this on the side, and open. And I don't even need to use this version. I'm going back into Visual Studio 8. So back into our original problem here. So I don't know if you were able to see this from last time. So this is the example I've been working on for a little while, and the screen is gonna flicker when I plug my monitor back into the computer. So the screen gonna go black. All right, so we back in action now. All right, so now. All right, so we're back in action now. All right, so now. So what we have here is a function. So what we have here is a function. This is the function called as fraction. Let me get the comments on the screen because I want to make sure we still following this. So this is the function right here. This is extremely important because this function is going to do the work of computing the greatest common factor, GCF. So like I said, if we have a fraction written in this form, 3/9. Well, that's not a good fraction because that's 1/3. So let's get another fraction on the screen. And I'm gonna do this one. 6/8 plus 3/7. So the LCD in this case is 8 times 7 is 56. That's what this function is going to compute. So that's what the function. So y'all following me with this one actually, huh? So we got the fractions on the screen. And the next thing we're gonna do is start computing, and we're about to start working on this fraction. So this part, these 4 ints right here, this is what, which if you're a C++ programmer, this is the function prototype. Function prototype. That is just part of C++ syntax. Whenever you create a function, you have to have a function prototype before the declaration of the function. And what I mean by declaration is this part right here. So this is the declaration of the function. That's the function declaration. So what this means, this is telling you exactly what the function is going to do. So right here, we're going to take the 2 denominators and multiply them. You remember how earlier I did something like this? Let's say we have 8 over, we might have something like 8 over 6 plus 7 over 5. So this function, this line right here, is going to take these 2 values and multiply them. So GCF is going to equal 30. So that's what we're going to do. So we have 2. So that's what we're about to do right now. We're going to just compute the GCF of 2 functions. Y'all ready for that? So we're going to get user input right here. These lines is getting the user input. Yep, so we got 2 phones in the building. Right here with a thumbs up. And the way I have this set up is I can't really access everything, so you already know. So there we go. There we go. So now you can see it. All right. So let's continue writing this. So right here, this return value I'm going to call the function. And I'm going to do it in a complex statement. So watch this. So I just create, this is an instance of fraction. So what I'm doing here is I'm using this class called fraction, and then we give it a numerator and a denominator. So let's do that. So let's see what we're gonna have. I'm actually gonna create 2 of them. So there it is. And I'm also going to create 3 to hold the results. So we have that stuff. So you could look at that as so this will be fraction 1. This is fraction 2. And when we add fraction 1, That's going to be the result. So you got that? And this is actually what the fraction is going to do. And we could compute that on the side. All right, here. So now it's time to actually start computing this. I'm moving this up into the part of the code where I'm actually declaring variables. All this stuff is variables. So I could say F1 F1.denom So we're going to get rid of this because this is not needed and this is not needed because we have two fractions. So what I'm doing now is I'm gonna cin and I'm gonna come here and do F1 dot numerator. See that? And right here we're going to do F1 denominator. You see that, right? So we're going to come here, F2 numerator. So that's what we're doing now. So we're using our class right here that holds the denominator and numerator. We just created two instances of it, and now we about to put values in those instances. So now it's time to move down a little further into this example. Let's run it, compile and run. And like I said, compile just means you're taking your executable, you actually creating your executable. Control F7 to compile. Well, we gotta have the right damn screen on. So I'm still running into. I left these denoms out here, so we're gonna still roll with the fractions right here. So I just got a comment. Let me see where my we got you do it in the building. Yeah, so you do it must have programmed in C++ before. What about that? Put your name on the block right there, boy. Oh yeah, so you do have been programming since the 70s. That's a good time there, man. So you probably done did some COBOL too, huh? So now we have our fractions and denominators. So you could actually start putting values in these things. So let's see if we can get this thing to run. We got a successful run. Now let's build it with a successful build. So this is the numerator. We have 2/3 and 8/7. 2/3, 2/, oh shit. So let's go back and fix this. See how the numbers are not in the right place. So I just have to go here and let's see, numerator, F1 numerator, F1 denominator. I'm gonna have to run this one more time to make sure we got, because that didn't look right. 6/8, 7/2. So I have to fix this input because, so I don't know if you can see this. So we have 6/8. Numerator, denominator. Oh, I see now. I see. So this is just getting it to look right. So right here is the correct print version of the fraction. So let's control save, and we're about to run this thing again. So you see that? Now we got the fraction. So we got 4/7. 8/2. We have the fractions printing out the way I want them now. That's right. That's the way I want this shit to look. Yes. So I'm gonna have to do a big salute on that one. So proper fractions printing. So now we could feed this into our. Now we could feed that into the function. So this is going to be a complex line where I'm going to do two things at one time. I'm going to assign a value to the function. I'm going to assign a value to the function. And I'm going to assign a value to our fraction by using the results of the function. So this is how you call a function and add to it. So sometimes you'll see this written on 2 lines or something like that, but the return value of this function, and like I said, we doing functions here. So let me do this right quick. So in this case, we have a function. We're gonna have equals 2x. In mathematics, you know, the answer of 2x using x, so we might have, let's say, something like 6. So f of 6 equals 12. So we're gonna take, this is the result. That's going the wrong way. So you're going to take the result here. So the result of this function is assigned to the value of fraction result. And you can tell that by scrolling up. When I scroll up, and right here, you see this called fraction, and you have a return statement. The return statement letting you know that we're going to return a fraction. So when you look at it, this is it right here. So these are the values I just input. See how when I call fraction F1 numerator? So numerator is going to be underscore D1. And F1 denominator. Numerator. Denominator. And what I'm going to do is I'm going to change these values up so it could be more readable since we about to start manipulating these values. So this is going to be numerator. Numerator, denominator, numerator, denominator. N1, D1, N2, D2. So we just fixed those values. So now you see D1, D2. Because I just put this shit in here whenever I just did this. So let's look at what we got here. So when I call this fraction, these values are here. So I could write the code for this. So N1 is just a generic value that we're gonna use to compute the logic in this function. So we can't talk about the exact values that I'm using here. Like I'm saying F and all that stuff. We're not worried about what I'm actually using here. So we're going to talk about N1 first because those are the values that we're using for function notation. It's just like if you write a function f of x and f of 3. I'm defining a function as 3x. So then when I get ready to use the function, 3 times 3. So all these x's, this x part is just like this. That's just the stuff that we're going to use to define our function. So you see, so that's why we have n1, this underscore n1, and when I'm writing code, I like to put underscores in front of the declaration values inside a function. That's just my standard, my style. And whenever you get in the code, and you might have your own thing, but this make it so when I'm working with these fractions, or when I'm working with functions, I know that these are the input values, because whenever the compiler start giving me errors, if I see an underscore value, underscore n1 or something isn't defined, then I know that I'm looking at the parameters inside of a value. In other words, another thing is, these things are called parameters. So we have 4 parameters, 4 int parameters. And so the difference between a parameter and whenever you use the function here, at this stage these are not parameters. These are actual what would you call that? Arguments. These are called arguments to the function. So parameters and arguments. And we got 2 different names so you won't get the shit mixed up. So now let me bring the chat back over. We got Holla at Your Boy in here too. I didn't even know he was in here. Must be way at the top somewhere. So now let's compute this value. So this is going to be real fast. So we got D1 times D2. That part is already done. So I'm going to comment this part out. And we do not even need this. Now, we're going to compute the numerator later, because the numerator is actually going to be the denominator. I just want to make sure we're going to return the proper fraction. So I'm going to just say equals 690. There's going to be a holding value for right now. And after we call the function, I'm going to print this stuff again. So now whenever you call it, it's going to print a second fraction with the results of our function call. So ran into a few errors, so let's see if we could get this part of it working now. Ran into a few errors, so let's see if we could get this part of it working. Now back in the day when I used to use C++ a lot, I wouldn't have to go through all this. Let me comment these lines out so I can focus just on this one. So it looked like somewhere I have a redefinition. So let's see, fraction as fraction. We're going to call it F result, because that means function result. So right here, these lines are not needed. So now I'm at the part where I'm trying to get the parameters and the input values into the function to actually work. And you're supposed to run into problems at this point, because I haven't programmed in this in a long time using C++ to do this. So let's see if we could get this to compile. So see if I can bring this screen up so you can see it a little better. So now you should be able to see this a little better. How that's looking? So now you should be able to see exactly what we're working with. So right here, it's saying redefinition of D1. D1, D2. Because I renamed this thing F result. This is where we computing the highest common multiple, the LCD, whatever you want to call it. That's this right here. So there it is. So I didn't have the declaration. See, in Python, you could just say GCF and you could just start rocking. But in this thing, you have to do this. So that means that I have a underscore D1. I'm about to make this a little easier here. So this means that I'm using this as a parameter in the function. That's too long there. So just remember, this means that. So now let's come back over here. F1 and F2. We putting them in the fraction. So now let's come down here to the part here, and now I'm gonna have to do all this with the underscores. So this is where this prototype crap gets a little messy. Somebody just texted me. Shit, 365. Let me take a look at this. Let me take a look at this money right quick. 1, 2, 3. Damn, that job left fast. So I always got to keep track of my hustles. So let's get back into what's going on. And one more thing. If you still following this stream, LaShawn holla at your boy is about to start his stream at 8 o'clock. So if you want to go over there and check his stuff out, he talks about phones and all kind of other stuff. Then then y'all know that he about to start streaming. But I'm gonna continue working on this because I'm about to knock this shit out tonight. So we're gonna get this thing to return to fractions, and then we're gonna come with an entirely new project starting next week. So I'm about to finish this up. So let me take a look at what's going on in the comments. So like a few people fall. I know Barry is about to roll out. Let's see here, baby boy. And I think Two Phones is still here. He got 8 people on deck still watching this. Big salute to all 8 of y'all. So now let's try and see if we can get this thing rolling here. Kenny Man is still here. Well, I think he is. Yeah, this mini master class. Yeah. I mean, I guess you could consider it a very small class. But let's see if we could get this shit working right. So, and the thing is, I only need one part of it to work. So let's see what happens when I try to compile this thing. Undeclared variable. Let's see, save, Control F7. All right, so we just made a lot of progress here. We got Latrell in the building. Let me turn this off. The air conditioner, I mean, it's starting to get a little cool in here now. All right, so now let's see if we could. So right here it's saying F result can't be value. So I'm gonna have to. So I'm gonna take the GCF and assign that to the denominator, like that. And I actually have this same line right here, so I'm basically repeating that line, so I don't need it here. So now let's do a Control F7. Denominator equal GCF. All right, so I left off a semicolon. Equals underscore F1 we're going to do that to the denominator. We computing the denominator here. And we're going to multiply that by underscore F2 denominator. So now this should compile. So there it is. Successful compilation. So now let's see. So now let's run it. So there it is. Successful compilation. So now let's see. So now let's run it. So now let's do 3 over 5 and 8 over 2. So let's see what happens. So I'm still want to make. Oh, I commented that. I commented the rest of this stuff out. All right, that's why. So now I'm about to run this again. Let's do a Control F7 to. All right, so we got some few issues going on with this line. I don't think I have. Let's see. Result fraction. And I'm gonna comment this one out. So now I know to do that. So what I just did was put an inline. I just put an inline literal right here. And to show you that I'm not making up these words here, let me go into my programmer's dictionary here. So right here, a literal is data representing fixed values. See? So we can have C, like I just put this inline keyword here. So this is the literal. This is a literal, and all this other stuff going in here like that. And it's just representing fixed words. So in order for me to get this string to print, I have to put this inline crap here. But yeah. So I still kind of use that out of context. I fucked up that context, but now you know. So even a savage, which is wrong a lot of times, could be wrong. So let's get back into this. Let's compile this. And see if we could get our. I'm jumping the gun here. So you got 3/6 and 36/8. So I still have to fix this. This is the result. So let's see here. So I guess I could put a couple more inlines in here. Let's see, result fraction. Put three spaces here. Cause I'm gonna put another one here. And what inline is, that's kind of like, that's almost like putting another space in between. And I what happened to the last inline? There it is. So we're gonna put 3 spaces in between it. So that's what this is. This is like a space here. I mean, not a space. This is a new line. So we just put 2 of them here. So we just put us 3 new lines here. And now let's control F7. And now let's see what we got here. Control F. I wish I knew what knew my build. Let's see, Control F5, start without debugging. I'm gonna just start hitting Control F5 so I can get straight to this, so I don't have to keep hitting the menu. So let's go. I'm waiting on this thing to, maybe if I start typing. So we got our 6 and 5, 7 and 3. So let's see. So we got our 690 and 15. So yeah, so it's computing the LCD right here, 5 times 3, and I told you that the top one is gonna be 690. So that's right. So let me put another inline right here, because that's what's missing. And I told the function to make the numerator 690. So I could make this. 987. 504. Yeah. So we're gonna drop a zip code in here. So we still have a few people still checking this out. So I mean, so we got New Orleans zip code here. Control F7, and now control. What was it? Control F5, I thought. Yep, Control F5 runs the program. So let's put we're gonna do 4, 6, 7, and 4. So there it is. 6 times 4. So it's computing the denominators as it's supposed to. 6 times 4. So that's what I want. So this is what we're getting here. That's right. So now we're gonna come here and let me come here and make it so we know what we getting here. So before I call the fraction the new line, I mean this thing. So I'm gonna just change one of these lines to the fraction written the resultant fraction. How about that? Yeah, that's a good name. Resultant fraction. That's what we're gonna go with. The resultant fraction. How about that? Yeah, that's a good name. See, I'm talking to myself, huh? All right, so we're gonna Control F7 and then Control F5 to run it. All right, so we're gonna bring this over to the other screen. All right, so the resultant fraction will be 18. 6 times 3, 18. So now we're going to take this 18 and divide it by 6 and then multiply that by 2. We're going to take this 18 here and divide it by 3 and multiply that by 7. So let's do that now. So we're going to do all this in one line. Let's see, int. So we're going to do all this in one line. I'm going to do it in 2 lines because it looks like it'd be easier. I'm going to do it in 2 lines because it looks like it'd be easier. And then I'm going to take those and add them up and make that the new denominator right here. And then I'm going to take those and add them up and make that the new denominator right here. And then that's going to become the numerator for the whole function. And then that's going to become the numerator for the whole function. So you're going to go GCF multiplied. We're going to take GCF divided by F1 denominator. Underscore F1 denominator. And we're going to multiply that by the numerator. Underscore F1 dot numerator. And we're going to do the same thing down here. Except we're going to change the F1s to F2. That's it. Except we're going to change the F1 to F2. So let's see what these values going to look like here. So let's see what these values going to look like here. So I'm gonna just since we know the denominators are being calculated correctly. So I'm going to just say F1 denominator and F2 denominator. So I just want to see if those denominators are printing right. So now we're gonna do 4 over 3 and 6 over 8. So we're gonna have 18 and 32. So let's see how we got to 18. So the LCD is 3 times 8. That's 24. We're gonna take 24 divided by 3. 24 divided by 3 is 8. 8 times 4 is 32. So that's how we got the 32 right here. So right here we got 24 divided by 8 is 6. 24 divided by 8 is 6. 6 times 6. No, let me see. 24 going to 8 3 times. 3 times 8 is 24. So 3 times 6 is 18. So that's correct. So this is correct. So what we're gonna do now is just add those two numbers up and divide them, and we don't even have to divide them. So we're gonna just take these numbers on the bottom, and they already computed into the LCD. So I'm about to comment this line out because so these values are computed correctly. So the denominator is gonna be the LCD or GCF. And I'm gonna put that line. We're gonna put that line here. And the numerator is gonna be this. So I actually could just say move this down to here. So that's it. That's all this function is doing. So at this point, this should be the shit here. This ought to work. Damn, how many times I'm gonna say this should? This should work. All right, so now let's give it a run. 3 over 4, and we're gonna have 1. We're gonna do a little more. 6 over 7. So we have 4 times 7 is our LCD. So that's right. So we're gonna have and really you could just cross multiply to simplify this. So we're gonna have 21 plus 24. So that's how we got the 45. That's kind of like that's a little secret. So you just cross multiply. So we have our fraction printing the way we want. And so now, if you was to add, so you remember how I said the average of 3 functions? We're gonna get into recursion to do it for. So we got the function working. So we're gonna call that function within itself. So we're gonna wrap this up with a recursive call to the same function. Or at least we're gonna make it so we're gonna average 3 functions. So we have 45 over 28. So that's it. So then really the only thing you're gonna do is take the result from this one and call it again. Really, the only thing you're gonna do is take the result from this one and call it again. So the only thing I'm gonna do is right here. So the only thing I'm gonna do is right here. What did I call the? What did we call the function? What did I call it? What did we call the function? Right here. Right here. So what I could do is call this function and then take the results. Since it's returning a fraction, and then put another fraction here. So what we doing is so we could do as fraction. So what we doing is so we could do as fraction. So we could do something like this, and then so we could do something like this, and then as fraction. And then hard code some numbers in here. As fraction. So we could do. And then hard code some numbers in here. So we could do. So let's see. As fraction takes 2 fractions. So I just have to create one more fraction. So let's see. As fraction takes 2 fractions. So I just have to create one more fraction. That third fraction, that's too long. I don't like long. I mean, I like long names, but let me just say frac 3. There we go, frac 3. Denominator equals 8. And numerator equals 5. So in this case, we're gonna have a third function being added to this. We're gonna have a third function being added to this. Because we did say 3 fractions, right? So here go the third fraction right here. Because we did say 3 fractions, right? So here go the third fraction right here. Yes, see. And then we're going to take as fraction and multiply that by 3 and then do the reciprocal part. So we're going to do that in a little while. So let's get 3 fractions in here. So let's see. So we already have our result fraction right here. That called it the first time. So we already have our result fraction right here. That called it the first time. And now we're going to add our new fraction right here. And now we're going to add our new fraction right here. Yep. Now that's already compiling. That's looking good. Now that's already compiling. That's looking good. We're gonna do it 5, 7, 4, 2. So let's see. We have 14 as our LCD, 7 times 428 plus 1038. So that part is correct. I'm thinking it didn't do the third call to the function because I didn't capture the result. So where am I calling the third fraction? Fraction here. So as fraction, the third part right here. So we're gonna have to copy all this part over. And create a third fraction here. So I'm gonna call it fraction. Average fraction. And I could also use the assignment operator, which is the equal signs, and do this to it. But it might not work because that's not. I have to define what that means. But since we're returning a as fraction thing, so this might work. So let's see. If it don't, then I know how to fix that too. All right, so it did work. The compiler is kind of smart. It knows that what it's doing here. So let's see. We got a 3 here, a 5, a 2, and a 7. 35. Yep. So 21 plus 10, 31. So we're gonna do this part. We're gonna run this line again this time to do our average fraction. And I don't even need these stops down here. I could get rid of those. So we got our average fraction that we about to do all this stuff to again. Put us some new lines in between here. Right there. Christmas colors, right? And just name this the average fraction. But it's still not the average because we still have to do all that reciprocal crap. So So now let's run it. Two over 5, 3 over 6. And then we use this other fraction. So 22 over 30 became the resultant fraction. So what became the other fraction the third fraction we created. So let me see what the third fraction is. 8 over 5. So we got another fraction right here on the side, 8 over 5. So the reason why these numbers so big because we had another fraction, 8 over 5. Now this thing isn't reducing or doing anything, because that's why you could look at this and probably say that 326 divided by 240. You could probably divide this by 4. Well, we're not going into all those details, but yeah, unreduced, this is the answer. So we still have the reciprocal part to do, where you're gonna say the averaging will be, we dividing that by 3, so we're gonna take and multiply it by a 1/3. So then we're gonna call a function again with 1/3. So we're gonna come back here and call it one more time with the average function and 1/3, and that's gonna give us our true average function. Without going through the what is it called? Without going through all the reducing and all that crap. Let's see, reciprocal, REC. I think that's how you spell it. Reciprocal, damn, I'm gonna just call it. If not, it's probably not spelled right, so I'm gonna just call it REC. There we go. And the denominator will be, so we working with we working with 3 over 1. So let's see. So let me show you what I'm saying here. So if you have a fraction 2 over 7, I know you can't see that, so let me rewrite this. So you have a fraction 2 over 7. And you have another fraction, and you want to divide that by another fraction, 6 over 5. That's going to be 2 over 7 times 5 over 6. So that's what we're doing now. So this is why you got to have this reciprocal fraction. This would be called the reciprocal. That we're going to divide, that we're going to multiply this thing by. So now, let's do it. So we're going to say, the denominator is going to be 1. The numerator is going to be 3. Because you dividing by 3/1. So we have to actually do the reciprocating ourselves, because this, since we created a fraction, you have to do everything yourself here. So that's why we got this like this. So now let's do it now. We're gonna do a 3 over 5 and a 6/8. So the average of that fraction will be some number called 632/2. So that's basically 2. Yep, so that's a little less than 2. So if you was to put that in the calculator, it's gonna be, if you was to do the fraction average of those 3 fractions, it'll probably come back as 1.95 or some shit like that. So instead of having 1.95, you have 632/320. So yeah, this basic math could sometimes be a little tricky, fun at times, but that's what we have. So we just average those 3 fractions. So we have 1/3, 1/5, and 6/8. 1/3, 1/5, 1/3, 1/5, 2/6, and we also have this 2/8. So you just know that this is gonna be some fraction shit. So we're gonna, when we pick this video up, we're gonna check to make sure we're getting the right answers. So we done with calculating with the language part. So now we're at the part where we just have to make sure we computing the right answers. So this the savage scientist, Ed, governor of the state of Swampland, and I'm about to get ready to roll out of this bitch. So peace out.